Today we are going to discuss transistor as a game changer in integrated circuits design. I am Dr. Imran Khan. For more videos and technology updates, please subscribe our channel. If you have any question related to our video, please feel free to contact me. Electronic devices are shrinking day by day, where speed and reliability is increasing and transistor dimensions are decreasing. Integrated circuits and micro-nano electronic systems are becoming extremely complex with billions of components squeezed into small area of silicon. Due to increase in functionality and decrease in size, number of components have increased on small area in integrated circuits. MOSFET or metal oxide semiconductor field effect transistor is the workhorse of integrated circuit technology, the cornerstone of modern computers and telecommunications. Vast majority of contemporary silicon chips use the MOSFET as the active component. ENIAC was the first computer developed by US Army in 1940s. ENIAC was about the same length and weight as 3 to 4 double-decker buses and contained 18,000 electronic switches known as vacuum tubes. Despite its huge size, it was tens of thousands of times less powerful than a modern laptop, a machine about 10,000 times smaller. First transistor was developed at Bell Labs in 1948. Transistors were a fraction the size of vacuum tubes and used much less power and were far more reliable. But there was still a problem of linking all those transistors together in complex circuits. Even after transistors were invented, computers were still a tangled mass of wires. First integrated circuits was developed by Texas Instruments in 1958. Development of integrated circuit have reshaped the technology. The basic idea was to take a complete circuit with its all components and connections between them and recreate the whole thing in microscopically tiny form of surface of a piece of silicon. Here you can see the first integrated circuit. Intel developed its microprocessor in 4004 in 1971. It was having 1000 transistors and clock frequency was 1 megahertz. With the passage of time, Intel keep on developing the more processor. For example, Pentium 4 processor was developed by Intel in year 2000. It was having 42 million transistors and clock speed was 1.5 gigahertz. So if we talk about the latest microprocessors with billions of transistors, so before going to this topic, let me tell you that only MOSFETs are used in CMOS integrated circuits because of its speed. BJT are no longer used, because we know that MOSFET is a unipolar device and BJT is a bipolar device. Unipolar device means only flow of electrons and bipolar means flow of both electrons and the holes. As you know that electrons are faster than the holes, so MOSFET is faster than BJT. In year 2019, iPhone 11 was introduced by Apple. It was having 8.5 billion transistors. Similarly, in year 2020, we are expecting iPhone 12 with 15 billion transistor on small chip. So you can see that the integrated circuit technology is keep on evolving, where we are continually scaling down our transistors to integrate more and more number of transistors in small silicon area. Moore's law. In 1965, Gordon Moore noted that the number of transistors on a chip doubled every 18 to 24 months. He made a prediction that semiconductor technology will double its effectiveness every 18 months. So this law drives the semiconductor industry for last 50 years. So here you can see the relationship between the number of transistors and the number of years. So if you see here, from year 1975 to year 2020, number of transistors are continually increasing on the semiconductor chips. So here in year 2010 we were already having the chips with billions of transistors, and in year 2020 we are expecting a chip with 15 billion transistors. So number of transistors are continually increasing. Scaling. Technology shrinks by 0.7 per generation. With every generation can integrate 2 times more function per chip. Chip cost does not increase significantly. So because of this scaling, we are continually integrating more and more number of transistors in small silicon area. There are also some major challenges like how to design chip with more and more functions. Design engineering population doesn't double every 2 years. Hence, a need for more efficient design methods. So after 50 years, we can see the impact of semiconductor industry on our life. So we can see there is a huge growth in integrated circuit technology, and because of these integrated circuits, we are able to design a lot of imaginary things which are helping us in transportation, medicine, manufacturing, entertainment, energy, and information technology. So this was after the 50 years of Moore's law. We are already having smallest chip with billions of transistors and imaginary functionality. We are continually scaling our transistors. So like in year 1959, we were having the transistors in millimeters, but now in year 2015, we are having the transistor in nanometer lengths. And in year 2020, we are already developing the chip on 5 nanometer process technology. So we are continually scaling down our transistors to integrate more and more number of transistors on small silicon area. How does a transistor work? MOSFET. We use only MOSFET in our integrated circuits, CMOS integrated circuits. MOSFET is metal oxide semiconductor field effect transistor. So here you can see the simplest MOSFET structure. In the red, it's gate. In the green, it's source and drain. So you apply the voltage at the gate and the drain to control the current between source and drain. MOSFET can be used as an amplifier and as a switch. It has 3 regions of operations: cutoff region, saturation region, and the linear or triode region. MOSFET can be used as a switch in cutoff region and the saturation region. So here are some more multi-gate structures. As you know that we are continually scaling down our transistors. So we need to integrate more and more number of transistors into small silicon area. So for that, we need to develop more transistor structure. So here is the example of some transistor structure which are helping us in our reshaping our integrated circuit technology. So some examples of the FinFET structures on SOI and silicon, all around gate, FETs, and many other good structures. So here you can see the example of some modern transistors which can be used in future integrated circuits. Smaller is better. MOSFET performance improves as the size scales down. Switching speeds are increasing and the energy consumption is continually decreasing. So this happened because of scaling. we are continually scaling down our transistors to develop the more modern integrated circuits. Revolution in microprocessor. You know that today we have the modern microprocessors which have the billions of transistors, and due to this thing we already developed the devices with imaginary performance. Like we have this our iPhone 11, it is having the imaginary performance. This happened because of the transistor technology, revolution in transistor technology. So the transistor structures are continually changing because we need more transistor structure and more modern transistors to meet the challenges of future integrated circuit technology. So this was the lecture for today. If you have any problem, please feel free to contact me. Thank you very much for today. See you next time.